Welcome students. Today I will be discussing about the antimicrobials, that is for the beginning of first year. So that is coming under the inorganic chemistry unit 3, chapter 3. So antimicrobials, you know very well about the microbes. The microbes are the very tiny organisms that is present in the environment. So there are different type of microbes present in the environment like the bacteria, virus, fungi, and many more. So they are causing different disease in our systemic organisms or in the body part in different like anywhere. So to kill these microbes, the virus, bacteria, we are using some drugs or chemicals that is known as the antimicrobial. So we will be discussing about the inorganic antimicrobials that are specially designed with the inorganic substances and they will be working on the systemic circulation. So again, I'm discussing these are the agents which are used to destroy or inhibit the growth of pathogenic microorganisms. So there are 6 types and their mechanism of action is followed like antiseptics, disinfectants, germicides, bacteriostatic, sanitizers and sterilization. So these are the different type of antimicrobial. So how they are working on. So first coming to the antiseptics, that is actually the agents which prevent the sepsis by destroying the inhibiting the growth or microorganism living tissues. That means they will prevent the septicemia, that is the destruction of the tissues by destroying or inhibiting the. That means the growth will be inhibited, as a result microbes will be killed or they will be killed the growth. So they will be working on the living tissues like the antiseptic we are using in the hand for the killing of the infectious bacteria like this. So in case of corona condition, you have found that. So an ideal antiseptic should destroy the bacteria, spores, fungi, viruses, or any other microorganism of the living tissues of the host. So antiseptic can be used to prevention for the hands of surgeon, dentists, nurses, and pharmacists in the routine procedure where there is chances of lots of infection. Next, germicide. This is another category. So these are the agents which kill the microorganism. The more specific term which is used as bactericide. That means they will be killing the bacteria and the germs. So they will be killing the germs, different fungus, viruses. So they are specially known as the bactericide. They are cidal action. They having the cidal action. That means the suicide. That is the what can I say, death of the person. So bactericide means the bacteria will be died, fungicide, fungals will be killed, viruside, virus will be killed, amicide is amine. Now coming to the sanitizers. These are the disinfectants used to maintain the public health standards and called as the sanitizers. They are specially applied on the public area and the sanitation is covering for the surfaces like the surgical table, surgical glassware. So these are the non-living substances and their concentration is higher. Sanitation is mainly concerned with the cleaning and washing away of the organs. Now sterilization. There is one of the very good important procedure. These are the agents which are used to complete destruction of the inhibiting the bacterial spores, that means spores, where it can resist different environmental stress also. So where it cannot be killed, but the spores that can be killed through the sterilization of the heat or the different chemical irradiation is also there. So they can be eradicated through the different physical methods like application of heat or radiation, like UV radiation. These are or by chemical means, like chemical disinfection is also there. Now, the most important is the mechanism of how they are killed. We should know the mechanism, the cellular level. Generally, inorganic compounds are not used as anti-infective or systemic infection like antibiotics. So they are to be taken swallowing or taken orally or as a serum. But this type of drugs, germicide, sanitizer, disinfectants will be using by the physical methods. So they will be used for the topical application. So their mechanism is like different. Oxidation, halogenation, and protein precipitation are binding of the cell of the different bacteria viruses. Now coming to the oxidation, where it is occurs, the cell of the bacteria containing different proteins. So reducing group is present in most of the proteins, and these groups are required for the growth of the bacteria or for the survival of that microorganism. But these reducing groups are oxidized by oxidizing agents who alter the shape and conformation of the proteins and thereby alter its function and ultimately leading to the destruction of the protein. See, like metal ions, peroxide, metal peroxide, like hydrogen peroxide, halogens like chlorine, fluorine. These are the different very good antimicrobials. So see the structure, protein having a very complex structure. So there are some sulfur-hydryl linkage. So that sulfur-hydryl linkage, whenever will be oxidized, they will be broken down and it will be hydrogen will be removed. So as a result, it will be an altered protein. And as a result, the protein will be destroyed and the structure of the bacteria will be destroyed and they will be killed. Okay. Next, same procedure, halogenation, where most of the enzymes are protein in nature. The different enzyme that is present in the bacteria or viruses. Virus not protein, like the fungus, different cells. Where primary and secondary amine present in this peptide linkage, that is the CONH that is present in the amino linkage, amide linkage. Okay, so that undergo chlorination or fluorination, like this halogenation. Any halogen can destroy the structure. So they destroy the molecular shape and ultimately leading to the destruction of proteins. And generally, hypothalates act by this matrix. Okay. So you can see CONCl. The NH group is broken down to CONCl. As a result, altered is formed and the structure of the bacteria is broken down and they are killed. So this is one of the important procedure. So these are the mechanism. Next, coming to another procedure. Next, so that is the protein precipitation or binding. So that is used in case of acne or after the cutting of the beards. Then we use the alarm. So protein precipitation is widely used in downstream processing biological products in order to extract proteins and purify them from various contaminants. Like different contaminants can actually act on our skin. So astringent, that is one of the important agents. That is a chemical agent that helps in protein binding and helps to prevent the bleeding of the blood vessels. Suppose whenever you are just cutting your beards or any acne formation. So if there is any cut, so the blood vessels will be come out, and as a result, there will be infection. But if you use the astringent, the bleeding will be stopped, and the bacterial infection will be stopped. During cellular abrasion or irritation, it reduces the change of the strict and antiseptic action. So astringents are used in diluted form and applied to topic. So they may be used as the fitcary alum in the solid form or as a liquid like codicolon. So these are so they used as a clean the face and prevent acne breakouts, as well as stop the and hemorrhoids also. And relieve the discomfort and itching of insect bites. If there is any insect bite, like the bee or any honey, so they will also reduce that protein or enzyme from the surface of the skin. Okay? So this is one of the important. Like one of the agent is potassium that is used for the cleaning of the disinfection. Okay. Now coming to the formula, the different monoclonal drugs. So this is potassium permanganate. So formula is KMNO4, molecular weight 158.03, and synonym is permanganic acid, and standards have been less than 99%, but not more than 100.5% Km. Now methods of preparation, how it will be prepared. KMNO4 is prepared generally by mixing a solution of potassium hydroxide with manganese dioxide, and potassium chloride. The mixture is boiled and evaporate to yield the residue. So it will be then as a residue. Okay. Now, so potassium permanganate will be again it is next chlorine gas is passed through the potassium manganate solution and resulting to produce the potassium permanganate. See here K2MnO4 that is known as the potassium manganate. But whenever chlorine is passed, they will be again reduced and forming potassium permanganate. Okay. Now, physical properties. It occurs in the form of dark, purple, prismatic crystals with metallic luster. It is odorless, but taste is sweet and astringent habit. And it decomposes at higher temperatures. At higher temperatures, it will be broken and it will be color will be disappear. Chemical properties you see, it decomposes at higher temperatures. See, KMNO4, now potassium manganate and NO4 and okay. Now coming to the mode of action, the potassium permanganate releases the nascent oxygen that is with the third bracket oxygen, which works by the oxidative mechanism and inhibit the action of the microorganism in their. Now assay. The assay is based on the iodometric type of redox titration where it can be assayed to check the purity. Next it is used as a topical anti-infective. The solution is used as antiseptic in mouthwash and ulcers also. Or if there is any ulcers in the then the bacteria will be killed. It is used in the treatment of arthritis and in the venom barbiturate, antidote for venom barbiturate and alkaloids. Okay, so if venom barbiturate alkaloids is there, so it will be acting as an antidote. It is antireptic for veterinary practices also. Now the boric acid, that is another monograph. So that is having the formula of H3 and molecular weight is H2O3, where the synonym is boracic acid and oxalic acid. Free boric acid occurs in seawater, in plants, and nearly in foods. Although larger sources of occur in the combined form. It is the resonite, or borax, or calcite, or polyp. These are the ore or the minerals from where it can be prepared. Now preparation, boiling solution of borax is added to sulfuric acid and it produces boric acid. So Na2B4O7 reacts with presence of water, sulfuric acid, it produces the Na2SO4 and HCl. The solution is filtered and boric acid is separated and washed and until they uproot from the residue, from sulfuric acid. Okay. Next, coming to the commercially, boric acid is prepared by the decomposing certain naturally occurring minerals. So naturally occurring like calcium borate, that is one of the mineral ore, which can be used by the sulfur dioxide and in presence of water. And this calcium borate will be reduced to calcium sulfite again, and this calcium sulfite will be reacted with the borax to use the boric acid distribution. Okay. Next, coming to another physical properties, colorless, odorless, and white crystalline powder. It is six-sided triclinic crystals. It's slightly acidic and bitter in taste. It is soluble in water and alcohol, and stable in air and maintains 171 degrees centigrade. Its 1% solution is isotonic serum. Chemically, you can see when heating with 100 causes 1 molecule. So it produces H2, boric acid to oxoboronic acid. With alkali solution, it forms salt due to its acidic nature, H3BO3 and NaOH, Na2, sodium borate, or H2. Assay will be used based on the acid distribution. Identification test is aqueous solution of boric acid is faintly acidic. Its boric acid is local anti-inflammatory. They used in the preparation of various dusting powder. Boric acid, you know. So antiseptic cream and ointment, like Gorlin is used for, and in case of small children for wound healing. Okay. So they are having the bacteriostatic and fungostatic properties. Used as eye wash, mouth wash, and skin lotions. Emollient antiseptic ointment. Some of the skin is some wounds or infection, then it can use as emollient in the diaper rashes for the children, babies, and using the buffer solution to make medication. And there are some cautions like it is toxic if ingested, so it should not be ingested for internal consumption because it's very toxic in nature. Now there are some other formula like the iodine, that is very important. So that is used from the sea beach, from the chili saltpeter. They are the very type of different like the seaweeds, Laminaria adhita, and Fucus vasculosus. This type of drugs are this type of plant can iodine. And from chili saltpeter, like the different minerals can also deposit this iodine. So the iodine is very important, like violet bulb, black color, and luster is a shiny glow, and odor is strong or harsh odor. Crystalline nature is rhombic, and density is very heavy. Whenever you feel it iodic bottle or uplifting, then you will see it's very heavy. Now, chemical properties, molten iodine may be used as non-aqueous solvent for iodides. So, the electrical conductivity of the molten iodine has in part been described to the following self-ionization equilibrium. So, iodine will be equilibrium to I3 plus and I3 minus. As a result, they will be used as this ionized condition. Okay, the alkali iodide soluble iodide like the Ki, potassium iodide, they also use typical weak electrolytes and they are reacted with some compounds, and iodine or bromide, potassium bromide is used as different antiseptic agents. Now, mechanism of action, this is oxidizing agents and that can be doing the halogenous acid. So they forming the hypoiodous acid, I2, the H2O, HIO, which further releases the nascent oxygen, which does the oxidation of the microorganism uses. It is over-the-counter form and iodine used in the tincture, ointment, or the gel or to disinfect skin and prevent the cheat infection. Iodine kills the bacteria that can cause infection. This type of iodine is for topical use only. And you know the povidone iodine, that is one of the very povidone iodine that is used for the wound healing, different types. So another type of povidone iodine, that is one of the solution, which is known as the iodopovidone or polyvinyl pyrrolidine, which is one of the very important drugs. And physical properties also discussed here. It should be studied in class. Chemical properties also there. That is one same way. And assay is redox titration and uses it is chlorhexidine and dental denatured alcohol. It is used for the antiseptic and different cuts, wounds, burns, abrasions. Different actions are there. So there are another iodine solution, which is the glucose iodine. It is one of the important constituents. So they have the different medical values also. So this we are just ending. These are the important substances which you can be used for the antiseptic or active. Okay. Thank you. Thank you very much.